Okay, so hello and welcome back to another Unity tutorial. In this video we're going to be creating a simple spawning system in ECS using DOTS, the data-oriented tech stack. Let's get into it. But of course first I've got to thank my patrons, so special thanks to Flow State Games, Average Morning, CZ, Art Farrell, Buderay and Marie Baldwin. If anyone else is able to help support the channel monetarily, the link to my patrons down below. Otherwise there are also links down below to social media such as Twitch, Twitter and Discord. If you go and help me out by following on any of those, that'd be greatly appreciated. Now let's get to the video. For step one, we're going to have to create the component data where we define what we want to spawn, how often we want to spawn it, and where we want to spawn it. Then for step two, we're going to create the authoring component, which will tell Unity how to convert our mono behavior into an entity to use in the ECS system. And then for step three, we're going to create the system that actually handles the spawning, which will go through all the spawners and spawn things in. And then we can even, if we want to, spawn in spawners, and then those spawners will spawn more things in, and so on. It's up to you, right? This is just a simple example. If you haven't messed around with dots or anything before, I'd recommend you check out my previous video in this playlist. If you're not on the playlist, sorry, if you're just on the video normally, go to my channel and on the homepage you'll find an ECS playlist. It currently will only have 2 videos when you go look, but there might be more actually by that time. But anyway, let's get to the coding. Okay, so as always, if you want access to the actual files, my project files and scripts that I'm making in the video, you can go down to my GitHub link below, go find the repository dots tutorials or dots tutorial, and you'll find it there. So to set up this video and not actually waste time, I've already made the light and the camera, I've made prefabs from the last video, so it's all using the same stuff. I've made a new scene for it in a new folder, you'll see O2 spawning. And in prefabs, we've got a cube, which is just a cube, and a spawner, which is just a sphere, just to separate the two. Obviously, the cube's just going to stay like that, and that's what we're going to spawn in. It's going to be our prefab spawn. And then the actual spawner prefab will have the spawner data on there, and it's going to be converted into an entity with our code that we're going to write. And all I've done is I've made a subscene with a spawner, and obviously the spawner is just an object, doesn't have anything fancy on it really. So now let's actually get to the coding. If you go look in the scripts folder that I've made, I've got 3 scripts and they're all empty, so I've just made them ready right now. So let's get into the spawner. Okay, so the spawner file. In this file, we're going to have to actually make the component and basically define what data it is that the job's going to need to actually do its job. So we're going to need to make a struct for this. It's just a public struct. We'll call it spawner, like the file. And it's going to be inheriting or implementing iComponent data, which actually is just a tag. If you go look, it's actually got nothing in it. It's just a tag. And that's just to let Unity use it as component data. So presumably under the hood, the entities have a list of component data or something along those lines. It's probably a bit more efficient than that. But anyway, in our component data, we're going to define the component data, So we're going to have a public entity, and that's going to be the prefab we want to spawn. So we'll call it prefab. We're also going to want to know, well, how far away from our spawner as like a radius do you want to spawn things? Imagining it's like going to spawn in a sphere, like how far away? And to be honest, you might want to make it a set distance, you might want to vary it, it's up to you. I'm just going to go ahead and say each spawner is going to have its own distance. So I'm going to go float max distance from spawner. And what I'm going to do is in the system, it's going to pick a random value between 0 and this, and then it's going to spawn it that far away from the spawner. Okay, we'll get to that in the system. What else do we want? Well, we're going to want to know how often to spawn. So we could store it as a spawn rate if you want, or how many seconds between each spawn. So it's really up to you. We're going to go with actually a spawn rate, I guess. So let's go, actually no, we'll go with seconds between spawns. Okay, seconds between spawns. And then on the next one, the final one, we're going to want to store how long it has been since our last spawn, so we know how long it is to our next spawn. So let's actually just go with seconds to next spawn. And what can happen is the system can reduce this float, and as soon as it reaches 0 or less than 0, it will spawn one in and then reset it, and then you can keep going. So this is all the data a spawner needs, right? And that's all we're going to have here. Let's go over to the authoring component. Okay, so the spawner authoring is where we're going to actually write the function which gets called when we want to close our subscene and convert it from mono behaviors and game objects into entities. So we're going to have to make the class, so it's a public class spawner authoring, like so. Spawner authoring, and then this is going to be a mono behavior, like so. And we need to implement I declare referenced prefabs, and that's because I declare referenced prefabs as a class. Okay, so that's because we are spawning in prefabs like game object prefabs. We want to convert those to entities too. We have to declare this, and then we also want to say I convert game object to entity, because this anything with this mono behavior on is going to be converted into an entity. And then we need to implement both these, so we can just do control.enter, and here they are. So for declare reference prefabs, I'm going to put that at the top. Sorry, just going to shift that around. So what we want to do here is we want to say, well, these reference prefabs, we're going to add to them, okay? Reference prefabs dot add, and we could add a list, right? We could call add range, but we're just going to call add one prefab. So let's say our spawner had a list of prefabs to pick from, then we could have a list here, but I'm just going to go with one, right? Serialized field private game object prefab, okay? And we're also going to want to have on here the spawn rate and the max it's a float, sorry. If I can type again, max distance from spawner. Okay. Now we want to actually make an entity with that data. So we're going to want to say DST manager, which is the entity manager. That's just DST is what they call it. I don't know what DST actually stands for. Maybe it's dots or I haven't figured it out. It doesn't really matter. Anyway, add component data, sorry. Add component data. So to add component data, you need the entity you want to add it to and then the data to add. So we're going to add to this entity here that we've been passed in a new spawner. Okay, the new spawner component. So anything with a spawner behavior on is going to have a spawner component on it. And then we're going to set the prefab. So inside the component we wrote, the prefab is going to be equal to the conversion system, which you see here, conversion system, dot get primary entity prefab, like so. And that's essentially going to get the entity version. It's going to convert it. You know, I don't know the inner workings of it. All I know is it works, and that's all you really need to know. Converts game object prefabs to entities. And then we want to set the max distance. Whoops, we need a colon, a comma even. Max distance from spawner is the max distance from spawner. It's not very hard. So remember this max, I keep saying semicolons. So this max is referring to the max inside the spawner, and this max is referring to this max here. So you could actually write this dot max, but it'll just tell you it's unnecessary because it already knows that. It's not stupid. And then here we want the seconds between spawns to be equal to, well, not the spawn rate, because that's the opposite. It's 1 over. So we're actually going to say 1 over the spawn rate. So we can actually write in here. It's very easy for us as a person to read the spawn rate, but it would be nice if the code had it as a seconds between spawn. You could also have it seconds between spawn for yourself, but it's much easier to decide how many per second you want. So we can actually just do that conversion here. It's kind of a neat trick you can do, because you could call this every frame, but technically if you're going for the most performance, you don't want to call 1 over every single frame when you don't have to. Just call it on conversion. And we want to set the seconds to the next spawn equal to 0. Now that's already kind of defaulted to 0 anyway, but I think it makes sense just to set it here. It's up to you, you don't have to do that, but I've decided to go ahead and do it anyway. So that's it, that's the converter done. That's the authoring component finished. Let's go to the system. So before we create the system, I'm just going to go back into Unity because the system's going to be the biggest part. It's kind of like the end of the video, but it's a long end, I guess. So in the spawner prefab, we're going to go and add the spawner authoring. So we want a game object to spawn. Let's go and just get the cube prefab. It's been a bit laggy when it's doing stuff here. Oh wait, no, never mind. I just clicked on the wrong thing. My bad. So there's the cube spawn in. Spawn rate, well, we want to spawn perhaps 5 every second or something. And then how far away? Well, up to, I don't know, 25 units, right? There you go, done. Go back. There's my spawner prefab. And I'm just going to say close, rebuild. Okay. Now if I press play, that's done, right? We've now got a spawner, but you know, it's just got some data on it. Nothing really happens, right? Press play. It's not very interesting. Nothing happens. If we go over to the entity debugger, which you can open from window analysis, entity debugger, you can see we don't have a system for this. But if you go to all entities and we go and find our entity that has it, which will be, I guess, entity 3. Does it have the spawner on it? Entity 1, did that have spawner on it? Nope. Scene. Have we closed the subscene and saved it? Rebuild subscene. Because that game object... Oh, here we go. We've got an extra one now. So the spawner has a prefab index, so that'll be the actual thing to spawn. Prefab 1, whatever. And then we got the max distance from spawner, which is 25, and all this other stuff. Cool. But now we want to write a system to edit that data. Okay, so let's create the spawner system. So we're going to want a public class spawner system. Now, one thing just to say real quick is that we're going to be writing some stuff in here that's kind of a lot more complicated than the last video. I don't want to have to go and explain everything in detail. but I'll explain things briefly that you haven't met before. And don't worry, there'll be plenty more dots videos on the channel and ECS stuff. So if you don't get it now, you can obviously go look it up yourself, or eventually I'll bring up more videos on it and you'll understand it over time. But we're going to store, this is where the confusing stuff starts, an end simulation entity command buffer system. And I mean, I could probably create an abbreviation for this, but I'm just going to go ahead and use the full name. So essentially what this does is, I mean, it's pretty self-explanatory, right? When a simulation ends, and a simulation is kind of like, how do I explain simulation? It's almost like a frame, right? When it's simulated the frame, but not done the rendering or anything. A command buffer system, okay? So what happens is, if you use multiple cores on your computer, right? Your processor has multiple cores, and you want to use as many as you can, because why not, right? Games normally run on one core, or maybe have, you know, game logic on one core and then rendering on another. I mean, it depends on engine to engine and whatever. But ECS is about using as many cores as you have available to run code as fast as possible, execute it as fast as possible across multiple cores. And certain things you want to do have race conditions, which means if you were to do them just whenever you get to them, certain things will happen before other things that shouldn't happen. I mean, I can give you an example of this in Unity normally, is, let's say, for example, you get some data and you update some UI, and if you had the code both running at the same time to get the data and update the UI, well, what if the updating UI code starts running first, and then you perhaps haven't got the data, so it's either frozen error because it's null, or it lags because it's behind a bit? What you should actually do is make sure that stuff happens in the right order. So a buffer system, a command buffer system, is you can, for example, call create component, add component, create entity, all these different entity-related commands. But you might want them to only happen in a certain time, like maybe at the end of the frame, or after the job's done, or there's all these different things. So we need to use a command buffer system to essentially store a buffer of all the things we want to do when it's done. Now, that might have completely confused some of you. It confused me at the start, right? I didn't understand this at the start. That's why my explanation might not be perfect, but I hope you guys end up understanding it. And we need to now override Oncreate, and this Oncreate gets called when this system is created, so at the start of your game, or when in the editor, it's actually just when you go back to the editor, these systems already exist actually. We're going to want an end simulation command buffer system, that's this, sending equal to world dot get or create system entity simulation an end simulation entity blah 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 blah, all that lot, right? Which basically just means if there is no system with this type already, if this system doesn't exist, we'll make a new one and then we'll get it, or if it does exist, we'll just get it anyway. So now we've got reference to the world's command buffer system, right? So we can add stuff to that buffer. Okay, now that's the kind of main complex thing out of the way. Now let's get into the just the normal stuff. So we're going to make a private struct for our job, right? It's a spawner job. There we go. Okay, and that's an iJob for each. With entity, okay? And because the with entity one, I'll explain in a second. Let's just put in what we need. So we want this job to happen on everything that has a spawner component, if I can spell right, spawner, and a local to world. So local to world is kind of like a transform almost. It allows you to get its position relative, basically, to the world. So we can spawn stuff in at our position. We can use this local to world. And it's not happy because we need to implement a function. So let's implement it. And it has an index. Now, this is why we have to use this with entity. If you use with entity, you get these two passed in, the entity and the index. We don't actually need the entity, but we need the index, okay? And then here we go. We've got ref spawner, so spawner. And we got ref local to world, local to world. Now, if you guys watched my last video where I did rotation, this is simple. We had a rotator and a rotate. I mean, I've got the files here if you want to go look in the system. It's a rotate job, iJob for each, da 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 da. Now, we used burst compile here, and sadly, we can't currently use burst compile here because we're going to write some code in a minute that isn't compatible with the burst compiler. Now, I've heard apparently it will be eventually, but not yet. So that means that this kind of system might seem slower than you would expect right now, but you will be able to use burst eventually. Keep your eye out for that. Keep your ear out for that, whatever you want to say. Essentially, you can't use the entity command buffer with burst, but you can still use jobs to use multiple cores, so that's fine. We still want to get the most optimization. And at the end of the day, when we spawn something in, we're not going to actually care about we're not going to change the position of the spawner, we just want to read it. So to read it, you just put before ref, read only. which is promising we're not going to edit it. If we do try and edit it, it will give us problems, and that has to be using Unity collections. I think I added that in. I didn't need it. Okay. Cool. And the spawner, we are going to change data on, so it can't be read-only. And these two have to be how they are. Okay, so now what do we want to do every frame, right? This is like writing an update loop inside your script. You want to say, well, let's get the spawner's seconds till the next spawn and reduce it by delta time. Now, we don't have delta time, and we're in a separate core, possibly, so we don't have access to time to delta time. We have to pass it in. So we go to the spawner job. We can make a constructor, a public spawner job. And we want to pass in, let's say, float delta time. And we want to say this dot delta time is equal to delta time. And then obviously we can just do this to create a private float delta time. And we might as well just make it a read-only float because it's not going to change, you know, extra performance. It's faster to access read-only fields. And then down here, we can change the delta time. Oh, sorry, we can change the seconds. And then after that, we'll say, well, what if the spawner seconds to next spawn is less than 0, right? Well, that means we can spawn something in now. So we can say spawner. I mean, we could even say if it's greater than or equal to 0, return. Just return, right? We don't want to run anymore. It's the same thing, right? But if we get to here, it means, well, now we can say spawner.seconds to next spawn plus equals spawner.seconds between spawns. Some people might think it makes sense just to set it equal to the seconds between spawns, but you'll actually not be consistently spawning because obviously when you reduce on a frame, you might reduce more than bringing it down to 0. You might go to negative 0.1, in which case you actually want to compensate for that. So you want to add, not set, essentially. And then after this, we want to spawn something in. So to spawn something in, we'll say entity. And we'll call it, make sure it's the entity class. We'll call it instance. And that's equal to the entity command buffer, right, which we don't have access to. So let's now add this as a field. So we're going to have a private entity command buffer dot concurrent, because there's different kinds, entity command buffer, like so. And then we'll just say here the entity command buffer, and we'll do the same. This dot entity command buffer equals entity command buffer. So all this stuff we're writing in the constructor is going to have to be passed into us through the job scheduler, which will be done, you know, in a minute. Is this happy? Can't convert that, so it's dot concurrent here. There you go. So back down here, when I've got the access to the command buffer, which is where we tell it to do things at a later time, we want to say instantiate. So it's going to instantiate it when it can. It wants an index, which we can pass through from here, this index, and an entity to spawn. Well, we want to spawn in the spawner's prefab. Okay, there you go, simple. We're now spawning that in. But after we spawn it in, we want to, you know, put it somewhere. We don't want it to just spawn at 0, 0, 0 every time. So we can then also on the entity command buffer tell it to set component. Set component. Now it wants an index, so we'll pass in the index again. An entity to set it onto. So the instance, the thing we just spawned in, we want to set some data on that, and we want the component. So we're going to say a new translation, which is, you know, moving, right? And on there, I don't need to explain every little thing. And here we want to set the value of the translation to, well, we want to be at the position of the spawner, so the local to world.position, plus random. So we don't have random yet, right? So we're going to have to pass in random. So that's the one final thing we want to get here is private random. So that's Unity mathematics random. Yeah, okay. This dot random is equal to random. And then here we just say random. So we pass through a random, and a random is in the Unity mathematics. It's a way to get random floats and ints and different numbers, right? It's different to the Unity normal random namespace because it's more performant. So if we're using this in all our different jobs, we want to use this. Random.next float free direction. So it's essentially a random vector free, okay? That gives you a random vector free if you're used to using normal Unity. Want to multiply that by random.nextFloat, which is just a random number between 0 and 1. But we're going to multiply that by the spawner's max distance from spawner. So what that's going to do, oops, too many semicolons. So it's going to say, get our position and add on a random direction times by a random amount between 0 and the max distance, right? So we're going to go off in a random direction, a random amount. Essentially, that's how it works, and that's just where we're basically moving it to when it spawns. And that's it for the actual, logic of the system. All we need to do now is actually schedule the job. So if I go outside the job here and zoom in a bit, we're going to write a protected override job handle. Well, it's on update, essentially. What we want to do is we want to make a new job. So var spawner job is equal to a new spawner job. And we're going to just say, okay, the end simulation blah, blah, blah is equal to, dot create dot to concurrent. Honestly, I can't explain exactly what this means, this concurrent stuff. I don't know yet, as something I want to research, but it's just a type of entity command buffer. I understand how that works, just not this special concurrent mode. Now for the random, we want to pass in a new random. And the random... Oh, wait, have I closed too many? Okay. So the new random wants a seed. So we're going to have to say uint to cast, uint. And then we have to use unity engine.random.range between 0 and, for example, int.max value. Doesn't really matter, right? You could use floats, but I'm going to go with int here. And then for delta time, it's just time.delta time. So it's time.delta time. And then we close that off, and I'm just going to put that onto the next line. Now, time exists in multiple libraries that we're using, so you just want to tell it we're going to use time as unity engine.time. It just means that we then don't have to write it down here. I mean, the reason we're doing unity engine.random is because we're also using unity mathematics.random twice. We're using random twice, so we have to say specifically here which one to use. But anyway, we've made the spawner job with the variable set that we need to set. And then down here we can say, well, the job handle is equal to spawner job dot schedule this input deps, which is from here. And then we want to call end simulation this dot add job handle for producer job handle. So it's essentially going to handle the buffer system, the entity component buffer system for this job. It's quite a long line just for something like that. I mean, obviously there's a lot of complex stuff going on under the hood, but that's a simple explanation of how it works. And we're simply just going to end up returning the job handle because that's what it wants back, right? It wants a job handle back. And there we go. That's this done. And that's the entire code done for this video. Let's go test it. Okay, let's go. So we press play. And I'm going to the scene view. And there you go, actually. You see, we're spawning things in all around within a 25 unit radius. Now, if you actually notice back at the spawn point, if I stop and start again, it actually spawns them in, then moves them after they've rendered. You see them popping in. That's something I've not actually yet managed to fix, and I thought this video was still ready to show you guys. If any of you can figure out why that is or how to, fix that, feel free to let me know. I'm going to do some research in my own time to try and fix it, and if I do, I'll push the changes on GitHub. So feel free to follow this repository on GitHub so you'll be notified of any updates, or just follow me on GitHub anyway if you want to. It's not exactly my main form of social media, so I don't really mind that much. But yeah, here we are. We've got a spawner system now. Just something really cool we could do to show the power of this. Keep in mind, spawning in tons of objects, like thousands, will still lag your game, just nowhere nearly as much as if it was mono behaviors. Let's go and quickly edit and just have some fun. Let's just quickly set the cube to actually be the spawner, okay? Essentially, we're going to say spawn in spawners, and then those spawners will spawn their spawners in. It'll run really well for a little bit, and then it will just completely lag out because it's a lot of things to spawn. So yeah, I hope you enjoyed this video. This is, I guess, the outro, watching... Actually, it's not even doing the right thing. Did I rebuild entity cache? That's probably the reason. Anyway, yeah, so thanks for watching the video. I hope you enjoyed the video. Go like and subscribe if you want to. Ask me any questions down below. I'll answer as many as I can, but I'm not an expert on Dotch just yet. Apparently it's spawning in some of each, but I mean, whatever, right? It doesn't really matter. We're spawning in tons of things. I clearly just set something wrong in the subscene. But yeah, thanks for watching this video. I'll see you guys next time. If you want more, ECS stuff, then let me know down below. But yeah, I'll see you then. Thanks for watching, and goodbye.